Today, today we will discuss about linked lists. A linked list can be uh, defined as a series of connected nodes. Here, each node contains a piece of data. Data may be any type, and a pointer that always points to the next node in the list. So each linked list is having head pointer. It always points to the first node in the linked list. Similarly, the last node always points to null, indicates that that is the last node, means the linked list is ended there. So linked list, there are three types of linked lists: singly linked list, doubly linked list, circularly linked list. We will try to understand the about singly linked list. So the you can see in this slide, this is an example for singly linked list. As I told you, linked list is a collection of nodes. You can see here it is a collection of three nodes. It is having the head pointer. It always points to the first node in the linked list. So this example is for singly linked list. Here singly means you can traverse this linked list in a unidirection, one direction. Similarly, you can see like in a singly linked list, each node is having a data field. It is for storing data. It may be any type. It may be integer or float or etc. Similarly, this is also having an address field. This is the address field for this node. This is the address field for this node. And you can observe here the first node address field points to the second node address field points to the third node. Here third node is the last node, hence it is having null. The operations that you can perform on single linked list, you can create a linked list, we can traverse a linked list, we can traverse a linked list, we can search for any element in the linked list, we can do insertions in the linked list. Insertion may be inserting a node in the beginning, inserting node in the middle, or inserting a node in the last. Similarly, we can delete the node. So the traversing a linked list, search we can search an element in the linked list, and we can insert a node or delete a node from the linked list. The creation of linked list. If we want to create a linked list, we will try to first understand how to create a node. So you can see here a node can be declared using, as a C programmer, assume you can use structure to create a node. You can see the node declaration here, struct node. As I told you, node is having two parts. The first part is for data and another part is for storing address of the next node. So here next is a pointer. It always having the address of the next node. I have declared now a pointer head. See now I create a now dynamically a node that is in fact the first node using malloc. It returns the address, that address I have stored in the head. So now the linked list is having one node. Assume if head equal to null always represents an empty linked list. So initially head is null, After creating a node and assign the address to that head, now the linked list is having one node. So you can see entire the logic here to create a single linked list. So assume create SLL is a function. You can see this function will create n nodes, one nodes assume. So you can see this function will return the node pointer. So I have written here logic, a for loop, it will iterate from 1 to n to create n nodes. I equal to 1 means the first node. I have created a node dynamically using malloc and returns that address and stored the address in the head. Now head points the first node. So if I equal to 2 means this condition is false, the else part will be executed. So you can see we can create another node, store in the PTR next, means the first node next part, first node address part is having now second node address. We are just linking now the second node to the first node. So the in so on and so on, this procedure will be executed for n nodes. You can see similarly, I read data for each node and store in the data field. So after this loop is executed, n nodes will be created and the corresponding data items will be entered. So now the PTR points to the last node. So we have to make the last node next should be null. As I told you, the last node should consist of null in its address field. In its next means address field. And finally, this function returns head. The second one, traversing a linked list. So traversing a linked list, assume here traversing means visiting each and every node once in the linked list. Think about now we want to display the all elements in the linked list. How here assume display LSLL is a function. It takes the node pointer as the parameter. So here also I have written a logic using for loop. The for loop will be executed starting from head to null. PTR equal to head to null. This loop will be executed. So the for each and every node, I try to print the data item on the console. So head is the starting node, the null is the last node. For each and every node, we are printing data on the console. So this is the logic. Similarly, we can search an element in the linked list. Think about this function search SLL is a function. It will search for the element, assume. So it is again taking the head as a parameter. So again, the logic here, this function asks the user to enter the search element that is stored in a key. So key is a local variable that is stored in a key. Again, the for loop will iterate from starting from head to null, and for each and every node, we are testing that node is having that node uh, having data key or not. If that node is having key as data, we will make flag equal to 1 and break. As a result, we are coming out from that a loop. So if you see the after for loop, we are testing whether flag equal to 1. Flag equal to 1 means the element is found, else element is not found.